This week, we move on to growth models, and we continue our study of data science. We looked at collecting data and then how to describe that data. And the type of data we're looking at is going to shift a little bit. So, for example, a data set that we've looked at a bit, where we have these variables per person, age and gender and hair color, for example. Could be blood pressure, lots of things we could collect. And any variable we look at, like age, each row or each entry here is for an individual. Now, the shift we're going to make is not looking at data for individual things or people, but looking at data over time. So we're going to have two variables we look at together, time and then something else we measure. Like, for example, I like to play on mountain bike trails, and right now the mountain bike trails are being taken over by tumbleweeds. And if we don't intervene, then those tumbleweeds are going to continue to multiply, and we're going to have problems. Now, sometimes that change is relatively straight, or maybe in this case, perfectly straight. So here I'm just guessing that if we don't intervene, we're going to have in a given acre 20 new tumbleweeds in addition to what was already there per year. So well, let's see, it looks like, no, I'm jumping by 40, excuse me. 20 to 60, and then 60 to 100, 100 to 140, and so on. So that's what we call linear growth. But it could be the growth is different. Maybe it's a percent change. So here I have an example where we're changing by month, and the mice in a certain area are multiplying, and they're increasing by 50% per month. So if there were 20 mice in the first month, 50% more than that added on will give us 30 in the next one, and then 45 and 60, and they'll just keep moving along like that. Notice that when we have a percent change, it has this interesting curve to it. Now, the first two examples, they were engineered to be nice, where I'm guessing at 40 tumbleweeds per year increase, or I'm guessing at an increase of 50% per month. So growth rate's 50%. We have this other idea of a growth multiplier you'll take a look at in this chapter. Now, in reality, things don't really line up perfectly. So if we take a look at the United States debt here, and these numbers are in trillions of dollars here. So this isn't $1.78, it's $1,780,000,000 would be the US debt in 85. And in 2022, the US debt was about 25 trillion. So here we can see the points don't really exactly line or curve up nicely, and there's some wiggling going on, but I can use some mathematics to find an equation for that, kind of like I was finding equations for tumbleweeds and mice. And again, in reality, the points don't line up perfectly, but we can see there is a trend here. So this type of trend that I am modeling with the US debt here is what we call an exponential or percent change, kind of like the mice at 50% increase per month. Okay, so more on that as you read through this chapter. And sometimes it's not so obvious the kind of change that's going on. So here I have CO2, so this would be the average CO2 in parts per billion in the atmosphere. And this is, I believe these measurements come from a station in Hawaii. And we have, let's see, every 5 years up through 2015 here. And we can see the average CO2 in the atmosphere is rising here. And does it rise in a straight line? Is it an exponential type curve, or is it something else? And that's a harder thing to figure out. And it turns out there's lots of tools that if you go on to take a statistics class, you'll learn more about how to figure out what kind of equation might be best to fit this. But just for fun, I'm going to stick a line on this. So let's go edit the chart. And what I'm doing here is a little beyond the scope of the course, but it's pretty easily doable on a spreadsheet. Excuse me. All right, so I'm going to add a trend line there. So here I can see if I put a straight line to it, in the beginning, there's some points above, and then they're below, and then they're above again. So that indicates the data has more of a curve to it. There's lots of different curves out there. So which one is it? Is it exponential or is it something else? Another type of curve we'll look at is what's called logistic, and logistic starts off exponential, but then it's got some limiting factors, so kind of a ceiling going on. So we're going to look at linear, exponential, and logistic growth. Have fun, do good math. I'll see you soon.